Isolating current transformer, or CT, conductors involve specific steps to ensure safety and proper functionality. Here's a guide outlining the process. Firstly, gather the necessary materials including a CT can, rope, and electrical tape. Secondly, identify the farthest right or left conductor within the CT can. These CT cans typically have multiple conductors twisted together. Determine which conductor is located furthest to the right or left, as it will serve as your starting point. Next, tie to the farthest conductor by creating a loop at one end of the rope and slip it over the identified farthest conductor. Tighten the loop until it is snug, ensuring a secure hold. Then wrap around in between conductors. Pass the rope around the next conductor, wrapping it counterclockwise. Tie a loop around this conductor and tighten it, maintaining the counterclockwise direction. After that, continue wrapping. Repeat the previous step for each conductor in between the farthest conductors, ensuring each is securely wrapped with rope. Tie off the rope once all conductors are tied off. Tie the end of the rope back to the farthest conductor to secure the wrap. This provides an additional layer of security and prevents unwinding. Use electrical tape to wrap electrical tape around the connections and rope to further secure them and prevent any movement. This helps maintain the integrity of the isolation. There are a few additional notes to keep in mind. The wrapping order, counterclockwise, is important to ensure that the conductors are isolated correctly. Adhering to this direction helps maintain the intended functionality. Use sufficient rope to wrap around all conductors securely, ensuring a tight and reliable connection. Double-check all connections before putting the CT can back in service. This verification step is crucial to confirm that the isolation is properly implemented and safe for operation. The importance of counterclockwise wrapping ensures the conductors are isolated correctly, which is crucial for maintaining electrical safety and system integrity. This method is not just a suggestion, it's a requirement for proper isolation. Using enough rope ensures that each conductor is securely wrapped, preventing any accidental disconnections or movement. Insufficient rope can lead to loose connections, compromising the isolation and potentially causing safety hazards. Before restoring the CT can to service, carefully inspect each connection. This includes checking the tightness of the rope ties, the security of the electrical tape, and the overall integrity of the wrapping. Any signs of looseness or damage should be addressed immediately. The process of isolating CT conductors is a critical task that requires precision and attention to detail. By following these steps, you can ensure the safety and proper functionality of electrical systems. The materials needed, the tying techniques, and the additional notes all play a vital role in achieving successful isolation. Each step is designed to contribute to the overall effectiveness of the isolation, preventing potential hazards and maintaining system integrity. The counterclockwise wrapping, the adequate rope usage, and the thorough double check are all integral parts of this process. Before commencing the isolation procedure, ensure that you have the necessary personal protective equipment, or PPE, including gloves and eye protection. This will safeguard against potential electrical hazards and ensure a safe working environment. The selection of rope is also important. Choose a rope that is durable, non-conductive, and suitable for electrical applications. Avoid using metal ropes or ropes with metallic components, as they can create a safety hazard. Proper training and understanding of electrical safety principles are essential before attempting to isolate CT conductors. If you are not familiar with this procedure, seek guidance from a qualified electrician or electrical technician. The purpose of isolating CT conductors is to prevent accidental contact with live electrical components, which can result in serious injury or equipment damage. By following the outlined steps, you can minimize this risk and ensure a safe working environment. Always de-energize the circuit before commencing any work on electrical components. This involves turning off the power supply and verifying that the circuit is not live using appropriate testing equipment. Never assume that a circuit is de-energized without proper verification. In addition to the physical steps of isolation, it is also important to maintain clear communication with other personnel working in the area. Inform them of your intentions and ensure that they are aware of the potential hazards. This will help prevent accidental activation of the circuit or other unforeseen incidents. The process of isolating CT conductors should be documented, including the date, time, and names of the personnel involved. This documentation serves as a record of the work performed and can be useful for future reference or troubleshooting. Regular inspections of the isolated conductors should be conducted to ensure that the isolation remains effective over time. Look for signs of wear and tear on the rope, electrical tape, or connections. Any issues should be addressed promptly to maintain the integrity of the isolation. Consider implementing a lockout tagout or LOTO procedure to further enhance safety during the isolation process. LOTO involves placing a lock and tag on the circuit breaker or disconnect switch to prevent accidental re-energization. The LOTO procedure should be followed in accordance with established safety protocols. The counterclockwise wrapping technique is crucial because it helps maintain the proper electrical orientation of the conductors. This ensures that the current flow is not disrupted and that the CT can function as intended. Using sufficient rope not only secures the conductors but also provides a visual indication of the isolation. The presence of the rope serves as a reminder that the conductors are isolated and should not be tampered with. The final step of applying electrical tape adds an additional layer of protection against moisture and corrosion. This helps prolong the lifespan of the connections and ensures reliable performance over time. The isolation process is not just about preventing electrical hazards, it is also about maintaining the integrity of the electrical system. Properly isolated conductors are less likely to experience shorts, ground faults, or other electrical problems. The frequency of inspections should be based on the environment in which the CT can is located. In harsh environments, such as those with high humidity or corrosive substances, more frequent inspections may be necessary. During inspections, pay close attention to the condition of the conductors themselves. Look for signs of damage, such as cracks, frayed insulation, or corrosion. If any damage is found, the conductors should be replaced immediately. The electrical tape used should be of high quality and specifically designed for electrical applications. Avoid using general-purpose tapes, as they may not provide adequate insulation or protection. When wrapping the electrical tape, overlap each layer slightly to ensure complete coverage. This will prevent moisture from penetrating the connections and causing corrosion. The rope used should be made of a material that is resistant to stretching and wear. Nylon or polyester ropes are good choices for this application. Avoid using cotton ropes, as they can absorb moisture and weaken over time. The knots used to tie the rope around the conductors should be secure and easy to untie. This will facilitate future inspections or repairs. The process of isolating CT conductors is a critical skill for electricians and electrical technicians. Proper training and experience are essential for performing this task safely and effectively. The cost of inadequate isolation can be significant, including electrical shocks, equipment damage, and downtime. Investing in proper training and equipment is a worthwhile investment in safety and reliability. The isolation process should be viewed as a preventative measure rather than a reactive one. By implementing proper isolation techniques, you can prevent electrical problems before they occur. The documentation of the isolation process should include photographs or diagrams of the connections. This can be helpful for future reference or troubleshooting. The photographs or diagrams should clearly show the position of the rope, electrical tape, and other components. The LOTO procedure should be followed meticulously, ensuring that all steps are completed in the correct order. This will prevent accidental re-energization and protect workers from electrical hazards. The isolation process is not a one-size-fits-all solution. The specific steps may need to be adapted based on the specific application and environment. Always consult with a qualified electrician or electrical technician before attempting to isolate CT conductors. The materials used should be stored in a dry and secure location to prevent damage or degradation. The rope, electrical tape, and other components should be readily available when needed. The isolation process should be integrated into a comprehensive electrical safety program. This program should include regular training, inspections, and audits. The goal of the program is to create a culture of safety and prevent electrical accidents. The isolation process is not just about protecting workers, it is also about protecting the environment. Properly isolated conductors are less likely to leak electricity, which can contribute to energy waste and pollution. The isolation process should be performed in accordance with all applicable regulations and standards. This will ensure compliance and minimize the risk of legal liability. The isolation process is a continuous improvement process. By regularly reviewing and updating the procedures, you can ensure that they remain effective and relevant. The isolation process is an essential part of any electrical maintenance program. By properly isolating conductors, you can prevent electrical problems, protect workers, and maintain the integrity of the electrical system.